The CPU is essentially the brain of your computer, or your car, or even your fridge, well, at least inside its control panel. It's the fundamental component responsible for running computer instructions, and if you understand how it works, you'll never look at coding in the same way. In its pure form, a CPU might look like this. It's a bit intimidating at first glance, but let's start with some fundamentals. A CPU's purpose is to perform a series of operations on the computer's memory. The memory of a computer can be understood as a massive table. Each cell contains 8 bits, which we call a byte. What those bits mean is totally interpretable. For example, those bits can represent the binary representation of a number. However, this chunk of cells can actually mean a message. The CPU's job is to access a byte from your computer and modify it. To differentiate between different cells in the memory, we give each of them an address, which is represented by a number. It is denoted in hexadecimal form because it's a compact manner to store numbers. Computers have absolutely gigantic memory spaces. We already know enough to build a primitive CPU which can read a byte from memory, increment it by 1, and store it back. Let's call it the level 0 CPU. If we take a look inside, it has 3 main components: a control unit CU, an incrementor unit IU, and a memory controller MC. If the CPU is the brain of your computer, then the CU is the brain of the CPU. Its main role is to control the instruction flow within the CPU. The incrementor unit actually increments an 8-bit number, and the memory controller can read and write that number. The wiring looks like this. As you see, I connected 2 wires from the CPU to the memory storage. Those aren't actually called wires, they are buses, which are the address bus and the data bus. Via the address bus, the CPU will be able to know which cell has to be modified with the incremented number. The data bus carries the actual number that needs to be modified. The memory controller, which controls the memory, will transfer to the CU the values of the address and data buses. This sounds good in theory, but it still misses quite a few key things to actually be considered a CPU. First of all, every CPU needs some kind of internal memory so it can remember what it has to do. In our case, the CPU needs to remember 2 things. Can you guess them? A number and a memory address. So, where does it store that? Well, we can dedicate a small area inside the CPU for memory components. This is called the register space, or the general purpose registers, GPR. A register is basically a small, super fast memory built into the CPU. We'll need 2 of them. Address register AR to store the address we're working with, and value register VR to hold the actual data. We can just hardcode the address to point somewhere. Alright, let's simulate. The control unit gives an order to the memory controller to read a value from memory. The MC then places that value onto the data bus, when the CU enables the data register to load it. Do you see the pattern? The CU is like the commander that orders the CPU to work effectively. Looks like we're done. But the CPU still doesn't move. It needs something to drive it. So we hook it up to a clock. In our case, that clock can be as simple as a button. Press it once and the CPU takes 1 step forward. With the clock in mind, let's execute the steps fully. The clock tells the CPU to run. Then the CU asks the memory controller to read the data situated at 001 in memory and sets it in VR. After that, the IO increments the value in the register, and finally the MC sends the register value back to the RAM. The number went from 27 to 28. What you've just learned is the most primitive CPU you could make. I call it the level 0 CPU. But there are 5 more CPU levels coming, some more insane than others, and from the next one we're getting started with a real CPU, which can compute actual math. Part 2 drops next week, and if you watch this from the future, just check the description for the link. As always, see you next time.